The first one we're going to go ahead and look at is how these values are provided for us. In this case, our domain values are always going to be represented by the x values. And they're all going to be possible values that we can input for our domain or for our values for x. The range values are always going to be our y values, which are going to be represented by what we're plugging into the function with. The biggest thing that you guys are going to get from these is graphing shows all. Graphs show both domain and range. One of the big apps that you guys probably did use from last year, at least if you were in Mr. Lee's class, was Desmos. How many guys are familiar with Desmos? Who had Mr. Lee last year? Any of you guys? He is a guru at that thing. So if you haven't pulled it out, pull it out, download it, use it. Okay? It's a great tool. It's a great tool. We'll look at it here, but I'm not as intricate. Yeah, I don't. I play PS4 for fun. What a nerd. I'm just kidding. Can't really say that when I'm a math major too. So Desmos is a graphing calculator app that you guys can download on your own cell phones. Delete a couple videos from Snapchat and you guys can have enough space for it. So you guys are good. One thing that we're going to kind of look at today is specifically looking at domain and how to find the domain values. So the first thing we're going to look at is our rules. Now, we're going to put a title to this. This is the rules of domain. A more of a how-to. ... How to find them, how to make sure that they work, how to look for them. Okay. We only have 3 different types that we're going to look at. And those are the 3 that are going to follow the most of. Okay. Go ahead and copy down that first one there. The first thing we want to be able to see here is identifying simply how we look at the function itself. In this case, we have f of x is equal to 1 over 2x minus 7. We want to find values in which would make this true, or to find what x's we can plug in that would make this true. The way that we're going to see it is we want to be able to say that the denominator can't equal 0. So that's our first step. Step number 1 is just to say 2x minus 7 cannot equal 0. I know it cannot equal 0 because if that's 0, then it's a false statement. It's undefined. The second thing we're going to do is we're going to go ahead and solve for it. We got to be able to solve for that value. So we're going to add 7 to both sides using that inequality, that bad inequality. We're still going to get 2x is not equal to 7, dividing out by 2. 7 cannot be, or x cannot be 7 over 2. Okay. The final thing is just to write that. In this case, whenever you have a fraction, if you have a polynomial like a quadratic, we're going to have 2 no solutions for this. It cannot be another number. We'll practice that one in the next one. What we're going to say for the third and final is exactly that. x is equal to all real numbers. In this case, our symbol for real. Have we seen this symbol before? Are we okay writing like that? Okay. It's all real numbers, except for one instance in which it cannot equal 7 over 2. This is going to be our final answer to it. Okay, so we'll practice these. We'll look at different types, and we'll solve for these. So don't freak out. Okay. So this is our first step. Basically, writing the denominator can equal to 0, solve for the value x that we want, and then write all real numbers except the value that it cannot be. Does anyone know the second type that we cannot use, and which restricts our domain? How about square roots underneath the negative, or negatives underneath the square root? Okay. The number underneath the square root cannot be negative. Okay. What happens if we have a negative underneath the square root? It's I. What does I stand for? Imaginary numbers. Okay. If it's imaginary, we cannot make a solution out of this set. Okay. It doesn't exist. It's made up. Why did they introduce it for math? I knew a long time ago, but I don't know anymore. Okay. It's not real. We cannot define 3i in the real world sense of things. It doesn't make sense to us. Okay. So what we want to be able to see here is this means that any form of the function square root, where the variable is in the square root, has a domain restriction. Basically what we mean by restriction, meaning it cannot be that value. Okay. If we were to use a square root of x, x cannot be -1 because we'd have -1 underneath the square root. For our example, we're going to look at our g of x function, 2 plus the square root of x minus 4, using the following steps. So practice, look at those steps and copy those down. And we will get right to it once everyone copies those. If you don't have Desmos, I would highly recommend you download it. We're going to look on it tomorrow when practicing some of these graphs. So pull it out. If you need you need computer, we'll pull the computers out. Oh, we'll do that. We'll pull computers out. Go to Desmos and graph some of these things. Now for our function here, we're given g of x, so I'm going to rewrite it. G of x is equal to 2 plus the square root of x minus 4. And we're just going to follow the steps for these. Write the expression underneath the square root must be greater than or equal to 0. So underneath the square root happens to be x minus 4. So I'm going to say x minus 4 must be greater than or equal to 0. That must be true. If it's anything less than 0, it's negative, which can't be done. We're not good. We're going to go ahead and solve this inequality. It doesn't matter the 2 outside of it because we don't care about that value. It will add to the domain. It will add to the domain, but we just can't make that inside underneath the square root 0. The second thing we're going to do is we're going to go ahead and solve out. We're going to solve that inequality. Very simple. What should I do to solve for that inequality? Add 4. So I'm just going to get x is greater than or equal to 4. This is our solution. That's part of our solution. Okay. The third one is to write the same thing. Domain, and you can put D for domain. It doesn't bother me. X is equal to all real numbers, except, not except, where x is greater than or equal to 4. Done. Okay, that was kind of wacky, but I don't care. The other final thing that I want to say, so those are our 2 restrictions. The other thing I want to say is all the functions have domain of all real numbers. Everything else besides fractions and square roots have all real numbers. That's for number 3. Rule number 3. Rule 3. All of the functions have domain of all real numbers. If you have a square root or a fraction, it's bad. We can't do that. But if it does not, we can improve on that for those values. Meaning, linear, all real. Quadratic, all real. Polynomials, a to the x to the n plus b to the x to the n minus 1 plus whatever I make will still be all real. Exponents, e to the x look at the dot dot dot. If it's not a fraction, if it's not a square root, always going to have a all real number solution.
So if it doesn't have a fraction or a root, that's the answer. Just
we're going to do one more case of these, unless the domain is restricted, but it has to give you the domain restriction, and that's going to be our fourth rule, which is I think is probably the easiest one because it pretty much you don't have to really find the domain because it already gives you it. Here we go. Can we move on? The other one and the final one is going to be our restricted domain will give us values inside the parentheses, meaning in this case, if you're given a restricted domain, meaning unless it tells you, it's going to give you the x input values. An example will be with something like this. I don't even care about the function. F of x is equal to 2x plus 7, something like this, where it gives you the domain restrictions of -2 is less than x, which is less than or equal to 5. And we'll just do equal sign underneath there. If it gives us a value for that, our domain is simply the restricted interval, which you're not going to see too many of, but we're going to talk about this when we get to piecewise. And have you guys done piecewise functions? Does that ring a bell, piecewise? Okay. How much more time do we have in here? 10 minutes? Let's do 3 examples real quick, and then we'll get you guys your homework. Cool with that? Should take us only 2 minutes to do. Okay, here we go. Let's look at our, let me change this up to like a decent color. We'll do old schooled yellow paper or white ruled. There we go. Let's use that. Right? Like, check it out too. I can make it like, check it out. I'm super excited about this. Like, I was like, we can write it on South America if we wanted to. Or Africa. Australia. Or we can go old school. Let's see if you guys remember this. Uh-oh, polar coordinates. Graph paper. Connecting the dots. Sorry, I'm getting too excited about this. Okay. We'll just do large ones. All right, let's look at 3 different types. Let's look at our, it says find a domain. These are going to be our examples. So find domain. Oh, is it? Is that not working? There we go. Let me change it. Let's go back into this background. I'll go back to my white ruled. Are we good? Okay. How fancy. Find the domain. And this is what you guys are going to pretty much do tonight. You only have like 5 problems. It's pretty simple. And the problems that we're going to get here, let's look at several different types. Let's look at our first one, where f of x, example 1, is going to be f of x is equal to 1 over 3x minus 6. Our example 2 will be where we're going to get, ooh, there's going to be, oh, let's change this up. Never mind, I'm going to change this one up. I'm just kidding. Psyching you guys out right now. I want to try to do something different for this. Let's look at, let me think of one. Is that factorable? Can that be factored? Minus 3. Yeah. Right? Can it be factored? What are 2 numbers? Minus, it will be minus 3 and plus 3 and minus 1? Yeah. Okay. Sorry. Okay. So I want to put that one out there. Let's do the next one where we're going to do these are just a little bit more advanced, nothing too crazy. And then we're going to do our example 3 is going to be okay. For our first one here, is it a fraction? Absolutely. So we got to be able to say that this bottom part cannot equal what? So x squared plus 2x minus 3 cannot equal 0. Can we solve for that? Can we factor it? Our 2 factoring terms are going to be x minus, or x plus 3, x minus 1 cannot equal to 0. So that means x cannot be equal to -3, and x cannot be equal to 1. So this is going to be our restriction for this. Our final solution is going to be, and I'll write answer, is going to be x is equal to all real, except x equal to -3 and 1. So those are the only two we can look at for those. And let's just change this to -1. No, let's keep it +1. Yes. This one. This one. Yeah. Change this positive to a negative. Yeah. Okay. Looking at our next one, we're looking at the square root symbol, so we're going to look at everything underneath the square root sign. We know that this value must be greater than what value? Greater than 0. So that's our only restriction. So we're going to go ahead and solve this one out. I'm going to add 1 to both sides to get 1. And then how do I solve for x? Take the square root. Plus or minus the square root of 1. So x can either be greater than 1, or x has to be greater than 1. Would that make sense for us? Okay, in this case that you're getting here, you want to go with the larger domain, the larger values here. Okay, in this case, it cannot be negative in here, but if we plug that in, 1 minus 1 is still going to be 0. So we're going to go with the following. Our answer is x is equal to all real, where we'll just put both of them, just so I can make it simple for you guys. X is greater than -1, or x is greater than 1. And we'll put more context to this tomorrow. Last one down below, what do we have? Do we have any square roots? Do we have any restrictions? What are we going to get for the last one? All real. X is equal to, boom. Easy enough, right? Here's your homework. That's not it. Oh, sorry. It's just the last part from yesterday. Take a picture of it as you guys get up. Find the domain of those two, or those 5, which is 35 through 43. We did already the first part. Bye, you guys.
What?
Easy today? Let's switch it.